giving you that the cosine of double the angle of 2 theta is equal to 1 over 3. And they tell you that the angle terminates on quadrant 1. For cosine of double the angle, we have 3 different equations that we're able to use. In this case, we're looking for sine. So I'm going to be, and since we're trying to solve for sine, we can only use the last one. It will be the best one to use. So let's go and write it down. So the cosine of 2 theta is equal to 1 minus 2, the sine square of theta. They are providing you with the value of cosine of 2 theta. They are telling you that that is equal to 1/3, so therefore I'm just going to replace it. 1 over 3 is equal to 1 minus 2, the sine square of theta. I'm going to move my 1 to the left because I say negative 1. I'm going to place over 1. So negative 1 plus 1/3 gives me negative 2/3. I'm going to place over 1. I need to have the same denominator, so I'll multiply by 3. So negative 3 plus 1 is negative 2 over 3. Negative 2 sine square of theta. I'm going to divide by negative 2. Divide by negative 2, so I can leave the sign by itself. And let me switch things around. So I'm going to have the sine square of theta is equal to negative divided by negative is positive. I'm going to change my division to a multiplication by taking the reciprocal of the second fraction. So it gives me the 2's cancel, so I just have 1/3. I'm going to get rid of the square by taking the square root on both sides. That will give me the sine of theta is equal to plus or minus. This will be the square of 1 over the square of 3. This is 1 over the square of 3. But since I cannot have a square root on the denominator of power minus, so I'm going to multiply by the square of 3. So it gives me the square of 3 divided by 3. But I do need to decide if it's going to be positive or negative. Remember, we're looking for the sine of an angle. And they tell you that the angle terminates on quadrant number 1. So therefore, sine in this quadrant is positive. So you're just going to keep the positive aspect. And that'll be your answer.